So let us go to the next example. And we go to the next example. You are going to get these things, members. I'm telling you. You are going to get these things, and later on, when you come back at school here, it will be just but someone has asked me, sir, when are we getting promoted to the next class? People, do you want to be promoted? Vanita? Vanita? Are you hearing me very well, members?
Yes.
People are off and on. I don't know why. Okay, let us go to the next example. Example 7. Use logarithm to evaluate this. So this is where we are going to use these tables very well. Use logarithm to evaluate 3, saying that example 7. Example 7. Example 7 is saying that use logarithms to evaluate use logarithm to evaluate 356 times 436. So to do this, members, we are going to use the log tables. And when we are using the log tables, we must make sure that we understand how to read them. But the first thing that we are going to do is we are going to draw this table that you are seeing in the left-hand side. So in the left-hand side, we are going to first draw the table by drawing the first row which has number, and this is where we are going to put the numbers that we are going to multiply. Then the second part, the second column, is where we should have the standard form. So these numbers which appear here should be written in standard what? In standard form. In standard form. So we write them in standard form. So we draw the second column here to indicate our numbers in standard form. Then the other column is where we are going to indicate these numbers in logarithm. In logarithm. So once we have our numbers in logarithm, then it's a matter of adding up those logarithm with those numbers, and then we find the answer log. So we do this. When we do this, then we are going to present our work very well. And the examiner is marking. We shall have the best presentation of our work. Those ones who have funny background images, like Alexandria, it is not good, please. Okay, so let us proceed. So the first thing is that we are going to write 356 where the number is. So the first one is 356. But remember very well that if you want to find the log of this, you must first standardize this number. You can't find the log of 356 unless you first standardize the number. So to do this, we are going to write 3.56 times 10 to the power. And because we have written this to 2 decimal places, how? We put a point here because standardization means there must be one digit first, then a point, then the other digits follow. So it means that we have written this number to 2 decimal places. So this is 1 and this is 2. So we shall write 3.56 times 10 to the power 2. 10 to the power 2. Okay, now what we are left is, we have to, how do we call this number which is here? This number which is here is what we call the character, and this one is called the metissa. So we have, so the number which is here is what we call the character, and this one is what we call the metissa. Now what we are going to do is we are going to first write the character, and this character is the power of 10. So the power of 10, we come and write it here, point. If that power was a negative, we would have written it 2 with a bar on top. But since the number is positive, so we are going to just write 2, then point. Then, where are we going to get these other digits that follow here? For us to find those other digits, we are going to use the log tables. And to get the log tables, we want to find the logarithm of 3.56. 3.56. So I'm requesting you, I know you have log tables. Do you have them?
Nope.
Okay. So hold in a minute. Okay, members, welcome back. Now, we have to get the log of 3.56. And how do we get the log of 3.56? We get it from the log tables, the log tables. So this is what we are going to do. We are going to go to our log tables like that. And then we are going to go to the part where we have not anti-logarithm, no, we are looking for logarithms, correct? So these are the logarithms. Now we look for 35. We look for 35. 35. We are looking for 35. First of all, we shall look for 35. This one which is here. Why am I saying 35? Because we are looking for 3.56. So you should know that these numbers, there is a point in between them. Though the point is not there. So it is 3.5, 3.6, 3.7, 3.8. The same way how they did not put the point here, but we know the point is there. It is 0.5563, 0.5575. So in log tables, they don't put the points there, but you should know those points are there. So when you're calculating, you should know that, and you should learn how to use the log tables. All right, so we are looking for 356. So we first look for 35, and then we shall go to 6. So we go to 35. This is 35, members. This is 35. So after we look for 35, so the first number which is here is 35, which is the same as 35 here, or which is the same as 3.5 here. So this is 3.5 or 35. I don't know, but I think you have got it very well. What I'm saying, 35. Now we go to the column of C, of 6. Members, go to the column of what?
The column of 6.
Of 6. So we go to the column of 6. This is, let me look for that column. Let's put that one down. So this is where the columns are here. 6 is here. So this is 6 here. This is 6 where my cursor is. 6. This is the column of 6. So 35. Okay, let me use this tool. We are here. And we shall go to the column of 6. There, isn't it?
Yes.
That's where we are. Hey, thing is moving. There, isn't it? So this is where we have the column of 6. Let me check very well. Yeah, this is 6 here. 35, 35. There. So which value is there? 0.5514. Are you seeing that? 0.5514. So when you're writing that, so we wrote that 2 for this 10. Now we are going to write this value which is here as 0.5514. Just add on 5, 5, 1, 4. Let me check whether we are correct. Are we correct, members? Do you see this? Members, are you following?
Yes.
Hey, respond.
Yes, you're following.
Okay. Now that is the log of 356 is this. Now we go to the next number, members. Our next number is 43.6. So 43.6. So I'll come and write 43.6 as my number. Now I have to standardize that number. Standardizing it means I have to write the number, this number first, then a point, then these other numbers follow. So I have 4.36 because it must be the first digit point, then other numbers follow. So to how many decimal places is this one written to?
1.
It is to 1 because you have moved from here only one step, holding it.
1 step.
Yes, one step. So we have to the power 1. And we shall come and write this one. We write it here as 1, then point. Now we go to our log tables and we look for the log of 436. Okay. So we are looking for 436. We are looking for 436. 436. Okay. 43. Let us first look for 43. It is here, isn't it? This is where 43 is. Then you look for 6, column of 6. The column of 6, let me see, column of 6 is this one here. This is the column of 6. So let me put my cursor there. And whenever I'm sloping down, I'm still in the column of 6. But I want to get 4, 3, 4, 3 first. Where is 4, 3? 4, 3 is there. Here. Okay. So this number which is here is the number I'm interested in because it lies along where I have 4, 3 and 6. So this number which is here is the one that I need. So I've written 1, but point now 0.6395. Okay, now let us check whether we are correct. Okay, are you seeing that? Are you seeing these members?
Yes.
1.6395. Okay. Now, from there, we are going to add. Why are we adding? Because we are looking at multiplication.
Six.
Okay. So now, here, when we add, let us add this and see. So this plus this, we get 9. This plus this is 10. You carry 1. This is 6, 7, 8, 9. 6 plus 5, what do you get? You get 11? 11, then 1, and you get 4. So you have 4.1909, like that. Now, we change this one to the other form where we have 10 to the power. So the first one here takes, we have 10 to the power 4 because of this 4. So we have 10 to the power 4. Now times now we get the antilog of this. Members, we have to get the antilog of this. Are we together?
Yes.
So here I can write antilog of 0.1909. So we have to get the antilog of 0.9. We may not write this one here because this is the answer of the antilog. But once we get our answer, we shall just put it here. So here we get the antilog of 0.1909. And we shall get it from the antilog tables. Okay, so let us, should we proceed? We proceed?
Yes.
All right. So let me first rub off this. Okay, so we go to our tables. There, now we go to the antilog. Antilog, where are you? Antilog, where are you? Where are you? Where are you? There. So I'm looking for 0. Let me show you. I'm looking for 0.1909. So I'm going to first look for 0.19, isn't it? This one. Okay?
Yeah. Yes.
Then afterwards, I will go to 0. So 0 is this one. Let me see. Is this the column of 0? Yes, this is the column of 0. Now, where's 19?
Yes.
0. So I have, remember, we 1 point, 1.549. That is the first one for 0, isn't it? Now I'm going to go to 9. Are we together? This value of 9 should give me this value of 9 should give me its answer here, and I write it to 0 point something. So this is for 0 here. Now I'm looking for the column of 9. First minimize this. I look for the column of 9. 9 should be this side because we have finished these other columns here. These are columns run from 0 to 9, and the number which was there was 0. Now I want to go this side where there is 9, where we have mean difference, and I look at 9. 9 is here, but I must stop at, let me first get my get this arrow. So we are here, isn't it? There.
Yes.
Up to 9, isn't it? And the number which is there is what? Is 3.
3.
So we write it to 3 decimal places as 0.00. Which number is there? 3, isn't it? 0.03. And then we are we add. So when you add that, what do you get? What do you get when you add that to that?
1.552.
1.5,
Come on.
5,
52.
5, 2.
2.
1.552. Correct. So it means that now our answer, when we multiply 356 times 43.6, it gives us this antilog here, which is this one, 1.552. 1.5 is the antilog of this, times 10 to the power 4. So there we get. What do you get if you multiply that, members? Let us multiply. I don't want to use. What do we get? We get 5, 1, 5, 5, 2, 0. Members, are we together? Yes. So let us first, can you multiply with a calculator and see whether that is the same answer?
Yes, the same answer.
Same answer. So that's how we multiply using logs. Any question?
Yes.
Yes, Lynette.
Yes. Chana, when you're doing exams, do they give us the log table?
Yes, my dear, you'll be given log tables for free. Another question? You don't have any other question? Okay.
Yes.
All right. So let us proceed. I expect you people to be writing. Kabami and your friends, I expect you to be writing. Now, can we go through this other example here? So they're telling you that it's a fresh page. Someone is giving me background there. Who's that? Just reduce on your volume. Cynthia, just reduce on the volume, please. So we have, they're telling us to use example 8, example 8. Use logarithm to evaluate, use logarithm to evaluate 0.0417 times 0.00928. You're going to use logarithm to evaluate that. So without looking at the working, can we do that, members? So the first thing, let me do this. The first thing is we are going to draw our table. So we have that. Here we have number. Here we have, what do we have here? The second column?
Standard form. Standard form.
Standard form. Then the next one we have
Logarithm.
Logarithm. Okay. We shall have that and that. Okay, now let us fill in that first number is 0.0417. So can we standardize that, members? So this is 1, 2, isn't it? 1, 2 point. So we have 4.17 times 10 to the power negative what? This time it's going to be a negative because you have moved to the right. So it's going to be a negative. Okay. So we shall come here and write 2 and a bar because this 2 is negative. 2 and a bar. This 2 is negative. Now we are going to look for the log of 1.17. So let us look.
Is it?
Yes.
It's 4.1.
Okay,
Under
4.17. Sorry, 4.17. That was slip of a
Teacher,
tongue.
it's 4.1.
Yes, dear. It is true. It is that. Okay. So let us look for 4.17. Okay. So where do we have 4? Here. Okay, that is 4.1, isn't it? Here. 4.1. Then we go to the column of 7.
7.
Column of 7. So let me use this. So this column, this first column is of 0, then that is 2, 1, 2, 3, 4, 5, 6, and 7. So the answer we have there is 6201. So we shall write 6201. So 6201. Okay. So we go to the next part. The next part we have to find the number. We have to first write the number. And the number that we have there is 0.00928. So we are going to standardize this. This is 1, 2, and 3. I repeat again. This is 1, 2, 3 point. So I have 9.28 times 10 to the power negative 3. 1, 2, 3. So I'll come and write here with 3 bar, then point. Are you ready? We look for the log of 9.28. Are you ready?
Yes, we are ready.
Okay. So let us go to that column of 928. There. So this is where we have 92. This is 92. Now we have to look for the column of 8. So starting from 92, we go and look for the column of 8. Like there. Sorry? Yes, any question?
No.
Okay, so that is 0. That is the first column of 0. Second column of 1, 2, 3, 4, 5, 6, 7, and 8. Huh. So that,
Excuse me, teacher.
yes.
Yeah, keep quiet.
Sorry?
Teacher, it's 9.28.
9.48, not 2.
0.8. And here, in the Logarithm table, we're still going to 9. Is there an invisible decimal point in between of 9 and 2?
Letitia, let me first show you here. The question is 0.928, isn't it?
Yes.
Uh-huh. So we have standardized. We have standardized. Are you seeing this? Yes? Letitia?
Yes.
Uh-huh. So we have standardized and I've got 9.28, isn't it? Times 10 to the power negative 3. So we have to look for the log of this. Yeah?
Yes.
So to get the log of this, so it means that I want you to look very well here. This is 9, 2. So 9, 2. So there is a point between 9 and 2. Are we together? All these numbers are written to one decimal place: 1.9.0, 8.9, 8.8, 8.7. So this is 9.2, and then we look for that column of 8. So the column of 8 is this column here. Are you seeing this?
Yes.
So when we go to 9, 2, this will be the value which is there. Are you seeing it? This one. So 9.28, and we are in the column of 8. The number which is there is the log of 9.28, and we can write it as 3.9675. 9675. Okay, let us see whether we're on the right track, because some of you may say, are we on the right track? Are you saying, are we on the right track? Remember, as you have seen, isn't it? Okay, so the next thing we are going to add. So we add up this. Okay. Shall add up those logs, even with their negatives. We shouldn't be afraid of negatives. So let us add this plus this. What do you get? 6. This plus this you get 7. And this plus this you get 8, isn't it? And 9 plus 6 you get 15. Point, you carry 1. So 1 is positive, and here we have negative 2. Negative 2 plus 1, what do you get?
1.
1. You get negative what?
Negative 1.
Negative 1 plus negative 3, what do you get?
Negative 4.
You get negative 4, like that. So now we are going to change it to this side. So now we go to this side. So that means that here we have 10 to the power negative 4 times the antilog of 0.5876. Are you seeing that, members?
Yes.
Okay, so we proceed and find the
Yes.
ant log of that. So we find the ant log of 0.5876. Okay, so the first thing is we are going to look for 0.58. So go to our ant log tables, ant log here. This is where we are. But you should remember the number we are dealing with. This is the number 0.5876. So we first look for 0.58 in this column here. In this column. Okay, so let us look for that. 0.58. Are we there?
Yes.
Okay, so that's where we have 0.58. It is here. Now we go to the next digit. The next digit is it's 7. This is where we have 7. This is where I have 7, the column, isn't it? So we must have a line 0.58. It is this one here. So let me use some of the tools here. 0.587 there. Okay. So that is 3.864. 3.86 what? 64. So I come and write. I have, so from this one here gives me 3.864. That's what I get, 3.864. Now, how about 4? Now, how about 6? So I continue to the other column where I have 6. The other column where I have 6. So let me continue drawing this to that column where I have 6. So from there, I continue to the other column where I have 6. Let me use green. So to the other column where I have 6, And which number is there?
5.
That number is 5. So that means I'm going to come and write. I'm going to come and add on. So for this one, I'm going to add on 0.00. You said the number was 5. The number was 5. 0.005. And then I'm going to add. So I get 9. I get 6. I get 8. And I have 3. So that means that my answer, when I multiply 0.0417 times 0.0092. Members, you come back just for 2 minutes. For 2 minutes when this lesson ends. So I have 3.869 times 10 to the power -4. And when you use it, what do you get there? So what do you get? 0.